All right, so let's take a look at some one of the more common tools that we use for analyzing data, to represent data. So there's quite a few ways to represent data, right? It could be just a comma-separated list. It could be a worksheet in Excel, right, where each one of the fields is just a column. It could be a tab-delimited file. But certainly there's a lot of very good techniques that we've learned to use over the years in our industry, and so typically usually it starts by using UML, right, the Unified Modeling Language. So UML, as you might know, is one of the most common graphical languages that is used across multiple developers, regardless of your background, whether you come from .NET, Java. If you've done any object-oriented programming, right, typically you should have seen some UML class diagrams at some point, okay? And UML is just one of the, class diagrams is one of the more common types of diagrams that we use to capture the nouns, to capture the verbs, to capture the relationships amongst data sets. In a programming language, Java, C++, C#, these are object-oriented representations of a UML class diagram, right? UML, it's a very rich language that allows you to capture all sorts of things that not necessarily all object-oriented programming languages allow you to capture, right? UML is much more generic, much more conceptual than any particular programming language, right? Programming languages have, over the years, right, evolved towards implementing certain, multiple ideas that have been around for quite a while already, right? I mean, you could do inheritance without an object programming language, just with plain old C. You could do object orientation with assembly, right? With anything, with BASIC, or if you just understand object orientation as a concept, right? If you're very rigorous, you could do object orientation with any language, even if it doesn't support it, right? But over the years, languages have evolved, right, to support many of these object-oriented ideas that have been proposed for quite a while, right? And UML is by far, the most conceptual understanding of what we mean by object orientation, right? Languages just happen to be one instantiation of those ideas, right? Meaning, C++ and C# support inheritance, because UML is object orientation. The idea, the conceptual model is there in UML. So yeah, as we know, right, the object orientation was a fundamental shift in the way we think about programming, where we used to think about programming with data and behaviors as two distinct buckets, right? Just two distinct classes of things, right? So here's the algorithm, and here's the data that algorithm operates on, right? And slowly but surely we realize that, no, wait a minute, they're actually the two things of the same thing, right? They're two faces of the same coin, right? That there is no algorithm without data, and there's no data without the algorithm, right? They have to go together. If I gave you a random set of numbers, 10 random numbers, you wouldn't know what to do with them, right? You would need some context. You would have to tell me, well, what is it? If I tell you it's a phone number, then you know what to do with it, right? The behavior is that I can call that number. So the number, the data all by itself has no meaning, right? Until I give you a context, right? If I tell you, say, social security number, then, I can do other things, right? Or if I tell you if it's a bank account number, then there's a whole bunch of other behaviors that are based on that. Yes. So data by itself means nothing, and the behaviors by themselves mean nothing, right? It's a marriage. It's a context, right? If I tell you it's just a plain old integer, then all the arithmetic operations are available to you. Yes. So object orientation was the idea that we're going to marry these two things, right? They have to be part of the same thing. They're not two different things apart from each other. So the idea of a class was that we would be able to describe these behaviors, describe the data, right? And that the behaviors would be able to operate on the data of the class. So classes will allow you to describe what the data was, right? But then you would be able to instantiate any one of them, any particular instance. So the way we document a class is through the use of class diagrams, where you have the name of the class, then various attributes, their type, right? Some context of what they are, and based on that context, then all sorts of behaviors go along with that type, right? Just so this class has all these behaviors declared down below, just like this type over here has a whole bunch of behaviors associated to it. Dates have a whole bunch of behaviors, right? Integers have all sorts of behaviors. If it's an employee, it has a whole bunch of behaviors associated with it, right? So here we're capturing that this particular class has this particular data type and these particular behaviors down below, capturing also the accessibility, whether they're public, they're private, or they can be inherited from their parents. So that's classes, and then inside each one of these would be referred to as an attribute, right? The different pieces, the atomic pieces that make up the whole of the entire class. Some of them being multi-valued, right? They can be many of them, or some of them might be optional. This one says that it's optional, right? There could be one instance of a date of birth, or no instance, right? It's optional. So this represents the cardinality. How many of these dates do I have? Right? Just here, either 0 or 1. And multiplicity tells us how many of anything there are, right? So this tells me about the multiplicity, right? How many date of births I might have. Here are some of the more common ones. Typically, it's denoted by a bracket where you have the minimum and the maximum. And some of the more common ones are minimum is 0, maximum is 1, or just exactly 1, or there's 0 or more, so it's optional, right? And there could be many of these, or there's at least one. I need at least one of these, right? And then I can have any number of those. So these are one of the more common types of multiplicity, right? There's also stereotypes that allow to declare certain concepts that the language itself does not capture itself, right? So certainly classes is a core concept that UML captures. But if there's anything else that the language does not capture, right? It has a mechanism for extending itself, right? If the language does not capture it, that's okay. We have a stereotype. You can create your own concept, right? By putting it in double pointy brackets and then enumerating, putting a tag there, putting a label there that means something to you, right? This is something that it means to you, right? To your team within your concept of your team. Now there's some very popular enumeration. There are very very popular stereotypes. One of them is enumeration, right? Enumeration is a very very common stereotype, right? That it's widely used. And it allows us to capture the idea that an attribute might have multiple values, and these are all the allowed values for an attribute of this particular movie genre type, right? Notice that everything is really an enumeration. For instance, say an integer. An integer is an enumeration, yes, that goes from minus min int all the way to plus max int, right? It's an enumerated data type, and all the valid values are very well known. We don't call it enumeration, we call it an integer, only because it's a very common enumeration. It's such a common enumeration, we don't call it enumeration, we call it integers. Same thing for username, right? Username is the enumerated combination of all the characters concatenated together, right? Going from empty string with all the possibilities of a valid string. Yes? So it is also a numeric data type, but it's so large, the set of valid values is so large, right, that we give it a special name. We call it a string. Yes? But if you want to declare your own enumerated data type, right, for instance, movie genre, it can only have 4 values, right? Sci-fi, horror, comedy, and whatnot. Meaning that any variable, I could declare a variable here and say that it is of type movie genre, meaning that that variable can only take values from that enumerated data type. Notice that even though we use the class, we use the same box that we would use to declare a class, these are not attributes, right? These are not attributes as these are, right? These are attributes, yes? Instead, these are what? It's a list of valid values, right? These are not attributes, right? Movie genre is declaring the values of an attribute, right? Of which these are the possible values, right? So that's distinct. We'll come back to that a little later. Specialization and generalization. This was one of the big breakthroughs in the idea of object orientation. The idea that we could, instead of declaring attributes for a whole class of types, we could instead create a hierarchy where top-level classes would be more generic, and anybody who would inherit, who could inherit from this top-level class, right? So that we wouldn't have to describe low-level implementations. They could inherit these things from higher above. So instead of declaring, so this might be an employee, and then you might have any number of employees. A full-time employee, a part-time employee, somebody who takes a quotas, or they get a bonus, right? So they all have different behaviors. So instead of and we identify that all employees have certain things that are in common. Yes, they all have a first name, they all have a last name, right? They all have a date of birth. They all pay taxes, so they have to have a social security number. So since they all share these things, well, why not capture all things that are common and put it in a higher level, right? And then only describe down below, describe the things that are special about those employees, right? If you're a full-time employee, you probably have a yearly salary, right? If you are a hourly employee, then maybe you have a rate, right, that you get paid, right? So those are very specific to those types of employees. So those we would describe in the derived classes, so we would capture all the common things at the base classes, and then we would declare all the common things in the low level ones, right? So yeah, so this was a mechanism that would allow us to reuse code and concepts, so we wouldn't have to replicate this across multiple. And object orientation allow you to create all these very, very deep hierarchies of classes. And we'll know one of the things that will be challenging is, even though this is very useful, when you're going to map this to a relational database, there's some really there's no one-to-one mapping of capturing this concept in a relational database. So we'll talk about some of those challenges. Multi-value attributes. Some attributes could have many values. So here's a 0 to many. So it could be 0 or more tags for a post. Associations allow us to. These are the verbs, right? These are the verbs that describe relationships between the nouns. So here is an author that writes a book, and a book is written by the author. So associations, the verbs are converted into lines, right? So the nouns are boxes, and the verbs are converted into lines between the boxes. And then it describes what kind of role each one of these nouns plays in the association. Right. So the roles typically would allow you to read the association in a literal sense. You can say author writes a book, or a book is written by an author. Right. So these associations allow you to capture these things. You can also capture multiplicities that would tell you how many instances of these classes are associated. So an author might write multiple books, right? For instance, one author writes at least one book, but probably many more. Or the other way around, you might have a book, and then you might have multiple authors for that book. Oh, right. This is just saying, what kind of questions to ask in an interview, right? You wouldn't ask multiplicity or what many to many. Don't use jargon, right? That we might use here in our industry with your colleagues. Don't use this jargon with your clients, right? They're not going to know what a many to many, a one to many, a one to one. They're not going to know any of that, right? Or associations, or generalizations, or none of that. So don't use any of those jargon. Association classes, when you have a many-to-many, where you have a many-to-many relationship between two classes, oftentimes this is enough. Oftentimes, just one line is enough. Right? This says that one author might be associated with many books, one book might be associated with multiple authors. But if you need to capture additional information about that association, right? That the fact of knowing that they're associated is not enough, that you need to capture some more information about it. Typically, you capture it with an association class that is a dotted line with another class that might capture things such as, right, so the author wrote the book, but we want to capture other things, right? So when did they write it, right? Did they edit it? Right, so we could capture other types of information about that association. Aggregation is these are lesser use, but still they're very useful. That is one type of one-to-many relationship, but additionally captures life cycle relationships, right? If the lifespan of certain objects depends on the lifespan of another object. That if one object disappears, then the others must disappear as well, right? Or not, right? So what is the dependency? So for instance, if I remove a page, right? If I remove a page, do I also remove a widget? Probably yes, right? But it depends, right? It depends what the business decides, right? And depends on how you interpret it. Say I'm using Facebook and I want to leave Facebook, right? And my understanding would be that if I leave Facebook, then that means that all my posts, all my data goes with me. I mean, that's my conceptual model, right? That at least that's what I would interpret leaving a social network, right? That belongs to me. But maybe that's not the interpretation from the business side, right? So for me, it's a composition, right? I die. Everything goes with me, right? But from Facebook's point of view, it's an aggregation, not a composition, right? If you're gone, I still keep the content, right? It's still mine. So yeah, is it an aggregation or is it a composition? That's again depends on who's interpreting what the dependencies of the lifespans of these are. Composition, right? So if I remove a page, would it make sense to keep the widgets, the headers, and the videos, and the movies, and the HTML, and would it make sense to keep that around? That makes no sense, right? So yeah, they would go as well. All right, so there it is. So that was a whirlwind, just going through UML, and a lot of the diagrams I'm going to be using all throughout, and we'll talk about it in much more detail as we need it, when we need it.